lava and microorganisms, but it also fastens the decomposition of feeding mediums. That's why WRI doesn't only depends on lava digestion and assimilation, but also depends on the rate of decomposition of the organic materials. The ECDF is the efficiency of conversion of digested feed, which measures the percentage of feed being consumed by the lava converted into biomass. Overall, you can see that the ECDF of sludge tailing is much higher compared to coconut endosperm waste, despite having lower WRI value. That means they eat lesser, but they have higher conversion efficiency. This suggested that the sludge tailing had higher nutritional quality compared to the coconut endosperm waste. The ECDF of unfermented coconut endosperm waste here at 0 mil had the lowest ECDF value despite having the highest WRI value. That means they eat more, but they have the least percentage of feed being converted into biomass. This could be attributed by the highest energy loss via metabolic cost. That means the larva lost a lot of energy via respiration. And from here, you can see at 1 mil of EM1, the highest ECDF value is recorded. This suggested that 1 mil of EM1 is the optimal condition for the growth of BSFL. The lipid content and lipid yield are basically the same thing, except the lipid content records in percentage, while the lipid yield, we are looking at how much lipid is contained in the body of a larva. From here, you can see that the BSFL that are being fed with unfermented coconut endosperm waste and also sludge tailing had the lowest lipid content and lipid yield. That means they are not pre-treated with EM1. This reflected the limited nutrient availability in unfermented organic waste materials. This is because it hardens the lava digestion and also assimilation due to the complex structure of lignocellulosic waste structure. However, after the addition of EM1, the lipid content and also the lipid yield started to increase. This is due to the enzymatic breakdown of the lignocellulosic structure, lignocellulosic waste structure, which makes it easier for larva digestion and also assimilation. And from here, you can see at 1 mil of EM1, it has been recorded that the larva has the highest lipid content and also lipid yield. And from here, we can suggest that at 1 mil of EM1 is the optimal condition for larva growth and also for the production of the lipid. This is the biodiesel profile that I have obtained from my project. From here, you can see that C10 was the dominant or primary FAME species in all BSFL throughout all samples. And C12 or lauric acid was the secondary most FAME species. The ST0 had the highest SFA content, while ST1 had the lowest. And for MUFA or monounsaturated fatty acid, for ST1, it has the highest value, while ST0 had the lowest. And lastly is the PUFA, which is polyunsaturated fatty acid. The PUFA content were low across all samples, while there is an increase in CEW1 and also ST1. To further check whether my biodiesel that has been produced has a good quality or not, I have further confirmed them by comparing my biodiesel and with various international biodiesel standards. And it has been proven that the biodiesel that has been produced from my BSFL in all feed mediums demonstrated good quality and also compliance with various international biodiesel standards. In conclusion, the waste that are being fermented with 1 ml of EM1 are the optimal condition for BSFL growth and also lipid production. And the BSFL biodiesel across all samples were reached in C10 and also C12. And lastly is the untreated CEW had the highest WRI or waste reduction index, while sludge tailing has the lowest. The waste reduction index in sludge tailing increased with the volume of EM1 fermentation, while coconut and the sperm waste declined. For acknowledgement, I would like to express my sincere appreciation to my supervisor, Dr. Lim Jun Wei, and also my friends and colleagues for helping me throughout my project. Thank you.
Thank you, Ms. Nurin. So, I think one question for you by Dr. Wong. Okay. This question regarding just wondering to what extent do fermented sludge tailings and coconut and the sperm waste enhanced with EM1 meet the criteria for optimal lipid yield and biodiesel conversion in black soil? You can read it in the chat box because it's quite long.
Okay.
You can read the chat box. You can
Just
see the
wondering.
question.
Yeah, I can see.
Okay. Okay, so can you repeat back the question?
Just wondering to what extent do from sludge tailings and coconut enhance meet the criteria. Meet the criteria for optimal lipid yield. Amazing. And how you justify the selection of one substrate? Okay. So a question from Dr. Wang. Thank you. So Dr. Wang basically asked me just what extent do fermented sludge tailings and coconut endosperm waste enhanced with EM1 meet the criteria for optimal lipid yield and biodiesel conversion in black soldier fly larva? And how would you justify the selection of one substrate over the other for scalable bioconversion systems? So this is from here. So basically, sorry. So basically, I actually confirm the optimal condition due to certain conditions. Let's say from ECDF, that means how much the feed are being converted into biomass. So the feed being converted into biomass, which is ECDF, it is actually related to the lipid content. And from here, you can see that 1 ml of EM1 in both feeding mediums had the highest value. And to further confirm whether it is optimal or not, that's why I have done the lipid extraction, and I have done the calculation for lipid content. And that's why I have picked the 1 ml of EM1 to be the optimal condition. And from the growth rate and biomass gain also, you can see that at 1 ml of EM1, the highest growth rate and biomass gain are recorded here. And that's how I further confirm with 3 analyses to confirm that 1 ml of EM1 is the optimal condition. And to further answer the question.
Okay,
Yes.
the second question is how long the treatment in your process? How long it took for the whole process?
Oh, how long? Actually, this took me about 6 months. The hardest part of my project is actually the rearing process, because sometimes even in a controlled environment, at the end of the project, sometimes I, let's say at the start of the project, I use 20 lava per container. That means per sample, there are 20 lava in a container. At the end of the project, sometimes some of the lava were lost. So that's how I had to redo again my project, to study again from the start. The reading process is the one that took the longest.
Okay, okay. Thank you, Nurul. So,
Okay.
reminder for all the participants in session 6, don't forget to register your attendance based on the link that paste on the chat box. Okay, so thank you, Ms. Nurul. So, we proceed with the Dr. Ngau Chin Hui. Okay,
Ah,
Dr. Ngau.
Dr. Dr. Ng Chin Hui tak dapat hadir tapi dia kenakan video.
Cerita video, habis tu kita nak play ke tak?
Ya, saya akan playkan.
Apa ni? Ataupun video tu kita KIV di live session ke? Boleh?
Good afternoon, ladies and gentlemen. I'm Ng Chi Hui from Universiti Malaysia Sabah. Today, I'll be presenting my project entitled Bimetallic Cobalt and Zinc Dope Graphene Oxide MOF for High Capacitive Supercapacitor. The conventional energy sources such as fossil fuel and natural gas have contributed to serious environmental problems such as greenhouse gas emission, ozone depletion, and so on. So, the shift to renewable energy is becoming urgent and essential. Supercapacitor offers a safer and more environmental friendly alternative for energy storing and energy delivering compared to the traditional system. While supercapacitor store less energy than battery, they can still deliver power much faster and recharge much quicker, making them ideal for supporting renewable energy sources such as solar and wind. By combining the strength of batteries and capacitors, supercapacitor addresses energy demand in a more sustainable way to reduce carbon emission. The main objective of this project, first, is to fabricate a robust supercapacitor composed of cobalt, zinc, graphene oxide MOF through fissile electrode deposition method. Second, to optimize the graphene oxide concentration using 0.1, 0.5, and 1 milligram per ml graphene oxide. And lastly, to evaluate the electrochemical performances of the MOF-based electrodes. Generally, this MOF-based supercapacitor electrode was prepared through a fissile electrode deposition method. A 3-electrode setup, which composed of working electrode, AgAg cell as a reference electrode, and platinum as the counter electrode, were used for the electrode deposition process. Then, the electrode was subjected for various materials characterization such as XPS, XRD, FESAM, and so on, as well as electrochemical tests which include cyclic photometry, galvanostatic charge discharge, and life cycle for stability purpose. The experimental section was separated into two sections. We first studied the optimization of graphene oxide concentration for high-quality, robust MOF-based electrodes. 3 different graphene oxide concentrations were studied, which are 0.1, 0.5, and 1 milligram per ml. Results shows that the least graphene oxide concentration, which is 0.1 milligram per ml, gave the highest capacitance of 243.75 farad per gram as opposed to higher graphene oxide concentration electrodes. This phenomena could be attributed to the agglomeration of graphene oxide at high graphene oxide concentrations that impede the flow of charges and ions. When we compare the electrochemical performances of MOF with and without graphene oxide, we notice that the voltamogram area of electrode with graphene oxide is somehow larger. Implies the addition of graphene oxide improved the charge storage capability, suggesting an improved ion transport and electrical conductivity in a system. The incorporation of graphene oxide enhances the electrochemical response by increasing the overall surface area, introducing additional electroactive sites, and reducing internal resistance due to graphene oxide render excellent electrical conductivity. Likewise, from the galvanostatic charge-discharge profile, the symmetrical charge-discharge profile of graphene oxide doped MOF electrode implies an ideal capacitive behavior, which indicates an efficient charge storage system. When we measure the galvanostatic charge-discharge at 1 A per G, the graphene oxide doped electrode render the longest discharge time, indicative its maximum charge storage capability, thus give rise to a high specific capacitance of 1242.63 farad per gram. Nevertheless, the specific capacitance plunge when the current density increases due to fast charging and discharging that causes an inadequate time for the electrolyte ions to fully access the active sites for chemical reactions to take place as well as for charge storage. On the other hand, the electrode without graphene oxide is poorer due to poor charge transport and limited electrochemical stability at higher current density. This could be ascribed to poor conductor of MOF. Since then, the graphene oxide doped supercapacitor electrode exhibited twofold higher in energy density and power density performance thanks to the graphene oxides that help to efficiently facilitate electron transport. Would to be mentioned, our obtained results are on par to the MOF-based electrodes that have been reported in the literature. The graphene oxide doped MOF electrode was subjected to stability tests. Upon 1,000 continuous charging-discharging cycles, this electrode could still retain 60% of its original capacitance with a specific capacitance deliverables of about 800 farad per gram. The degradation of this MOF-based electrode could be due to extensive swelling and contraction of the electrode during cyclic measurements. Hence, further study to improve the shelf life of this device is needed for future industrial realization. In conclusion, the MOF-based electrodes were successfully synthesized through electrodeposition method. By studying the graphene oxide concentration parameters, it is affirmative that supercapacitor electrode doped with the lowest graphene oxide concentration of 0.1 mg per ml is the best, gave rise to better rate capability, and contributed to high energy and power density performance. These are the references. And before ending, I would like to introduce my research group. So our research group is working on energy storage and conversion as well as water splitting for hydrogen production. If there's any interested postgraduate candidates or any researchers who are keen for collaboration, please contact me via chihuieng@ums.edu.my. Thank you.
So that's all for the video today. We cannot answer the question. So we proceed with the Dr. Muhammad Iqbal Ahmad. Yeah, Dr. Iqbal.
Okay, dah tadi lah. Sure.
Okay.
Okay, Assalamualaikum and good afternoon everyone. Thank you for Chairperson, Dr. Yedani. And then for this kind of research, I just want to share a small scale research based on my FYP students. So I have to give a credit to my FYP, Daniel Hakim Fauzai, is doing this kind of research study. So my topic is a numerical simulation on the dispensing distribution effect in LED encapsulation. Okay, as an introduction, LED have become a popular choice lah, according to this trend since 2000 until now. To put into perspective, LED have been penetration across automotive system, across to our lightings in the buildings and across towards the illumination and so on. These are the particular LED used and been using because of approximately 80% of the LED giving or converting directly to the light energy, and whereas 20% is remaining converting to heat. There is how the low consumption in terms of electricity have mitigate or have pushed the fact pushing that the industry to become more reliance or more reliable towards the LED acceptance. So as a problem statement in the basics, LED towards LED, I'm talking about electronic packaging process. So for LED processing, the encapsulation it was a critical step in LED manufacturing. If we regard to the scope of LED reliability and longevity, so in terms of that the problem statement, we have seen that the problem raised up in terms of micro void situations, whereas the air bubbles become the trap in the EMC because of the EMC trap, and then during the dispensing process, this lead the situation whereas we can say the mechanical stability issue, connectivity, and then it becomes more. It doesn't convert to light energy, but worst case is going to be thermal insulator, hindering an efficient distribution of heat distribution because of the micro void situation. Okay, going to be objective. Yeah, we want to see the impact of a dispenser parameter on a micro void formation using the CFD simulations. So yes, on this research, we are doing validation between experimental works and the simulation works. For the CFD itself, we are using a basics foundation software, which is the NC software. So in the UMK, yes, we have academic vision of the software. We are using the kind of academic visions. So it's just one parametric study for this kind of research, the needle heights for LED encapsulation. We have studies quite parametrics, numbers of parametric, including the speed, including the velocity, including the AMC properties and this. But for this scope, I just want to highlight the needle height effect towards the LED encapsulation. So I'm accessing 4 responsive variable in terms of the EMC, VOF, EMC velocity, pressure distribution, and time taken for EMC during the encapsulation. So you can see right side on this slide. One is the EMC, or is acronym for epoxy molding compound, and then we have the LED chips inside the EMC. This is the behavior or the configuration or the properties of the LED itself. Okay. To demonstrate the CFD, the reliable of the CFD to validate between the experimental works and simulation works. So we have done a simple setup. According to this, we have a small camera, we have a syringe, we have a LED chip itself. If you're talking about LED chip, we have thousands of different size of LED chip. We have choose one for this kind of study. So, and then we measure the dispensing needle height according to the EMC droplet. And then by managing that, we monitoring and then we configure the different pumps by using to pressurize the EMC to give a droplet as the encapsulation process. So it just zoom out a process for LED 5050 that we're using. So we have a dispensing needle and then the epoxy resin. For the simulation setup, we set up 5 different geometry with the dimensionless value start from 0.8 to 2.4, and then we give us boundary condition, and then from that we have to set up the governing equation. This kind of situation, I'm using the laminar flow. Apart from that, we have to go for UDF, user defined function, because to give is to mimic exactly the real parameter during the experimental works. And then what we managed to have to get is part of it. We have the mesh dependency test. From the mesh dependency test, we are choosing about less than 20,000 elements, unstructured body, using the hexagonal type of mesh. And then from that, we are using the similar type of EMC, and then time taken from 0 to 1.3 seconds. And then it just, if you see this timing, is 0, 50 to 100, but it come across equivalent to 1.3 for 100%. So by having this, we managed to get similar and closely less than 10% deviation between the simulation and the experimental model. So that means the laminar flow that we choose, then all the boundary setup and then all the meshing setup that we use is particularly matched very well according to this kind of study. So back to the parametric study, we want to go for micro void situation. From the micro void situation, I'm able to see we place a point A and point B to look at the impact of the height of the dispenser type. So from this kind of study, yes, we agree that the EMC time taken to drop from the higher height compared to the lower ones dispenser is we have a trend from low to high. It means the high giving more takes more time than time taken to drop until the chipset of the LED. This is the first case. And then from this kind of recording, yes, we agree on that. And then we see how the developing of the microvoid itself during the encapsulation. I'm just to say that this kind of encapsulation is no further with the curing process. We just stop until the encapsulation process only. So there is no curing process after that from this kind of simulation. So the developing of the microvoid, we can see the EMC pressure distribution is developing on a B point from for the low dispensing until the high dispensing, which is pressure at point A and pressure at point B. It seems across the line, I mean, the pressure distribution and the velocity distribution, the more higher that you give the dispensing height, that means the MC will be splashed and it will be developing more sizing of area in terms of microvoid. This can be measured accordingly, and then this is the proving by using if you can see on graph 4, the AMC volume of fluid. That means the developing of microvoid from, you can say, for volume of fluid, if more higher than 0.5, that means the bubble is transformed to the fluids. So means the higher the splash, that means they give a more higher in terms of the microvoid developing in that certain of area, which is located closely to that chip. Okay. Okay, I'm just to highlight the CFD capabilities. So I have do have various parameter, but just here is a dispensing height. So we just validating that CFD model is a reliable model, and then closely met between simulation and experimental, close to 10% the deviations. And then key findings from this kind of research is the dispenser height play a crucial role in terms of microvoid deformation, and then a shorter, which is 4.0 mm or HD, dimensionless 0.8, may provide more precise control in terms of dispensings, which is more higher or taller dispenser, give a splash or spray in terms of the EMC situation. So the purpose of we want to recommend a better in terms of height, in terms of the design perspective. So overall insight, we can say is dispensing in the height is a factor for encapsulation process, because this kind of manufacturing is a very fast LED encapsulation, 1,000 maybe at one time. So we have to get optimum value, and then we have to know the characterization once we inject the EMC towards the LED chips. So from that, we can see that the CFD may help or balance the multiple objective effectively according to the parameter, but this here is only the height parameter. Right, part of it, I just want to highlight the acknowledgement to Universiti Malaysia Kelantan for providing accessibility for simulation, and then come across to the physical model for this kind of LED study. So for the references, I come across about 8 references for this kind of study. So Dr. Ida, I think that's it for me for this kind of sharing section for LED encapsulation.
Okay, thank you, Dr. Iqbal. I have one question, a general
Yeah, that's right.
question lah regarding your research project. How can the encapsulation dispensing method ni influence to the vote formation and distribution during the apa nama orang panggil the encapsulation process?
Okay. How
How
we
encapsulation
evaluate?
dia tu influence kepada formations of void and distribution during
Uh,
the encapsulation process.
Actually multiples in terms of the parametric lah. One of it is the EMC properties lah. EMC properties, the dispenser heights, okay, the shape of the design chip itself. Okay, so for this kind of research, only I'm highlighting the height, dispenser height. So we want to standardize the speed. We have to standardize the chip design. We have to standardize the EMC properties. All of this, these kind of factors. So by having that, we can say that if you are using the same or similar velocity of EMC, but the different height of the dispensings. So we can see that the effect would be on the pressure distribution and the velocity distribution. Part of it, we can see the effect in terms of the VOF itself. These are the parameters that we want to see the output. That means we are generating more pressure in terms of the closely to A and point B area. That means it showing that it developing a micro void area towards close to the LED chips. According to the VOF also, we want to clarify whether this area A or B is actually void area or the fluid area. So we can determine using the VOF. So part of it, we can see the from low to high dispensings. That means slightly higher trend in terms of B area is compared to the A area for the developing of void formation for this kind of study.
Okay, I understand very well this project actually the Iqbal. Okay, thank you very much, Dr. Iqbal. So we'll proceed next presentation. We'll proceed with the next presenter. from Mr. Muhammad Taufik, then Muhammad Ilyas from UTM.
Hello.
Hello. Taufik? Yeah, we can hear you.
Share my slide first.
Okay. So you can share your slide.
Can you see my slide?
Yes.
Yeah, start now. Okay. Okay, Assalamualaikum and a very good afternoon to our respected chairman and panel. I am Muhammad Taufik bin Muhammad Alias, postgraduate student from Universiti Technical Malaysia Melaka. Today I'm here to present my study titled The Potential of Functionalized Graphene Anode for Lithium Iron Phosphate Battery. Okay, for introduction, I'll be talking about the lithium iron phosphate or LFP battery. This is a type of lithium ion battery known for their safety, long cycle life, and excellent thermal stability. However, despite this advantage, LFP battery have a couple of important limitations. First, they have lower energy density, which means they tend to be larger and heavier than other type of lithium battery. Second, they have poor electrical conductivity, which limit their ability to perform well at high charge or discharge rate. Understanding and addressing this issue is key to improving LFP battery performance and making them more effective for a wide range of energy storage applications. Okay, to overcome the limitation of LFP battery, particularly their low conductivity, graphene has emerged as a promising additive material. Graphene significantly improve electrical conductivity by enhancing both electron transport and lithium ion diffusion within the battery structure. And its exceptional mechanical strength and high surface area also contribute to improve the structural integrity and rate capability. By incorporating graphene, the electrochemical performance of electric batteries is marked enhanced, addressing key challenges and make them more suitable for high performance energy storage application. So for the problem statement, I mentioned that the graphite anode commonly used in lithium ion batteries face several performance limitations. They have a low specific capacity, around 372 mAh per gram, which restrict their ability to store large amount of energy and limit their suitability for high performance device. Additionally, the slow diffusion of lithium ion within the graphite structure lead to poor capability and increase the risk of surface lithium deposit, which can cause short circuit. Furthermore, the lithium intercalation compound form, which is LiC6, still exhibits low storage capacity and only moderate power density, making graphite less ideal for next generation energy storage application. That's the purpose of functionalizing graphene in energy storage application is to enhance its overall electrochemical performance. Functionalized graphene offer higher conductivity and lower resistance, which improve electron transport during charge and discharge cycle. Its larger surface area also provide more active site for lithium ion interaction, and while the stronger structure ensure better mechanical stability during cycling. Additionally, functionalizing promote faster ion diffusion and better compatibility with electron, making the material more efficient and reliable. This enhancement collectively make functionalized graphene a promising alternative to conventional anode material in lithium-ion batteries. So the research, moving on the research objective of this study, the first objective is to synthesize amine synthesis, the characterized here atom dot reduced graphene oxide, also known as RGO, anode material. This involves doping the RGO with elements such as sulfur, nitrogen, and fluorine to enhance its properties. The second objective focuses on evaluating the electrochemical performance of both doped and pristine RGO sample. This includes analyzing their specific capacitance and rate capability using half cell configuration. Finally, the third objective is to investigate how different the atom dopant influence the structure properties and charge storage mechanism of RGO-based inert for lithium-ion battery. Altogether, this objective aims to develop a more efficient and high-performance anode material to address the limitation of conventional graphite. Next, this slide shows the material and method used in our study. Graphene has a honeycomb structure made of carbon atom, giving it excellent electrical and mechanical properties. We use graphene oxide and introduce the atom like nitrogen, sulfur, and fluorine through one-step hydrothermal method. This atom modify the structure and improve electronic, electrochemical, and lithium-ion storage property, making the material more effective for energy application. The summary results showed how doping affect graphene structure. The broad 002 peak in reduced graphene oxide RGO indicate the partial restoration of its carbon framework with structure disorder. Nitrogen and fluorine dop samples show a sharper peak around 26 degrees, indicating improved graphite ordering and tighter stacking, which enhance the conductivity. The sulfur doped graphene display extra peak, suggesting the formation of small sulfur-containing crystalline region. In summary, nitrogen and fluorine improve structural order and productivity, while sulfur introduce complex structure that may boost electrochemical activity but could reduce the stability. Next, we use PSEM and EDS to analyze the morphology and composition of RGO and its dot form with sulfur, nitrogen, and fluorine. PSEM image show that pure RGO has a wrinkle, loose stack sheet, which provide a high surface area but also indicate some structure disorder. After sulfur doping, the sheet become denser and rougher, suggesting sulfur incorporation. ADS confirmed sulfur is present at 6.4% by weight, proving successful doping. Sulfur at defect site that enhance the lithium ion transport and redox reaction. The nitrogen doped RGO, also known as NRGO, appear crumpled and fragment, which increase the edge site and defect concentration, favorable for electrochemical performance. It show 1.7% nitrogen verifying the doping process. While the fluorine doped RGO is smoother and more compact, indicating better stacking and fewer defects. The EDS detect a 1.8% fluorine, which is known to improve chemical stability and durability during cycling. Overall, the EDS have confirmed the successful incorporation of each atom, while PSEM show the resulting structural changes. These modifications are important for improving the performance of RGO with anode in lithium-ion batteries. As we go to the cyclic voltammetry result, this slide show the electrochemical performance of RGO and its atom dot form. The CB measurement were done using half cell configuration with a scatter of 0.2 millivolt per second, and the voltage window range from 0.01 volt to 3 volt. As shown in the graph, the area under each CB curve reflect the material capacity behavior. A larger area generally means better electrochemical performance among all samples. Based on the result, the SRAO show the highest specific capacitance of 492.32 farad per gram. It was followed by RGO at 417.66 farad per gram and RGO at 278.39 farad per gram and FRGO at 223.07 farad per gram. This result suggests that the S dropping greatly enhanced capacitance, likely due to the introduction of redox active site and better ion transport pathway. The N doping also improved performance by increasing defect site and H exposure. In contrast, F doping leads to more stable but less reactive structure, resulting in lowest capacitance. Overall, its atom doping significantly affect the electrochemical behavior of RGO, with SRGO showing the most promising result for energy storage application. So the conclusion that I can make is the heteroatom doping effectively improve the electrochemical performance of reduced graphene oxide RGO for lithium iron phosphate battery anode. Second, the SRGO show the highest specific capacitance, indicating excellent charge storage and ion transport capability. SRGO and NRGO increase the surface roughness and defect density, enhancing the electrochemical activity. Then number 4, the fluorine doping improves structural stability but result in lower capacitance due to reduced conductivity. And lastly, compared to the metal oxide composite, doped RGO offer a simpler, scalable alternative with strong performance for next generation lithium-ion batteries. So the acknowledgement, the author would like to express their sincere gratitude to the Center for Research and Innovation Management, CRIM, Universiti Malaysia Malacca, UTM, for supporting and funding provided through the PJP Perintis Grant. The support has been instrumental in the ongoing progress of the research. Appreciation is also extended to all individuals who have contributed directly or indirectly to the development of this work. It is hoped that the outcome will benefit the scientific community and contribute to advancement in sustainable energy. These are some of the reference that we show based on our study.
Okay, thank you, Mr.
Okay.
Muhammad. So, we have two questions based from your research. One question from the Dr. Ahmad Zolizi. Okay, he mentioned that why did you choose functionalized RGO over other carbon, such as carbon nanotube or mesoporous carbon for the anode?
Because RGO has a larger surface area. Based on our study, we compare to the carbon or graphite actually, but we found out the RGO has a more larger surface area that can enhance the electrochemical performance. Based on our research, yes.
Okay, the answer can satisfy you, Dr. Zul? Okay, and then the second question from Dr. Nur Hafiza. How do you calculate the specific capacitance of the bare RGO since the leaflet shape is distorted? Based on PG result, if I'm not mistaken.
We use the formula that commonly used, which is the area divided with 2 times scan rate times with the potential window to get the specific capacitance of the graph.
even it can be able to apply even the light is like quite distorted.
Yes, because actually I keep the data using I measure the data using uh the Origin Pro, and this has a function that can calculate the area and I mean yes, the area of the graph lah.
Okay, then last question from Dr. Zaidi. Did you evaluate the thermal stability or safety aspect of the RGO with ANOT?
Actually, this is still ongoing research, and for now we will not go deeper into thermal stability and safety aspect and maybe on the next phase we will focus more on this aspect.
Okay. Okay, thank you, Taufik. Next presentation. Okay, thank you. And then
thank you.
now we proceed. Okay, now we proceed with the next presenter from the USM, Dr. Nurhafizah Desa. Okay, now the floor is yours, Doctor. Okay, Doctor. Dengar apa? Tak dengar apa.
Doctor, can you hear me?
Yes, can hear
I
you
have to
already.
use two devices just now. One is my
Okay,
from laptop for presentation
Okay.
slide, and for my audio, I think I have to use my phone. Is it okay?
It's okay. We can hear you clearly. Okay.
All right. So can you see my slide, right? Okay.
Yes.
I will open it as a slideshow now. All right. All right. So Assalamualaikum and good afternoon, everyone. I'm Dr. Nur Hafiza from Energy Laboratory, School of Physics, Universiti Science Malaysia. Today I'm going to share with you a part of our project entitled Complementary Analysis of Thermal Decomposition, Kinetics, Slow Pyrolysis, and Characteristic of Activated Carbon from Coconut fronds. So these are all my members in Energy Laboratory, Mr. Akinau and also Dr. Nohayati Abdullah. Okay, to begin, I start with the introduction and I separated it into three. The untapped potential of coconut frond. Basically, I'm using coconut frond, or I will call it along the way CF, which is the byproduct of coconut trees actually. And in 2019, the Southeast Asia alone produced about 23.5 million tons of coconut, and Malaysia's production of 0.5 million tons owing to its tropical weather. And while with other coconut waste such as shell, husk, pulp, and fiber makes up more than 60 million tons globally. Farmers often burn these fronds, polluting the air with CO2, carbon dioxide, methane, and so on, non-volatile organic compounds. And it's contribute to the climate change and also aggravating fungi and pest infestations. So this biomass is low cost, abundant, and sustainable resource that can be valorized to create eco-friendly products, reducing over dependence on fossil fuels. Another point is creating high-value activated carbon, whereby we found that the coconut fronds can be successfully changed or converted into valuable materials like high-quality activated carbon (AC) through a pyrolysis system and also chemical activation processes. Since CF biomass also presents an opportunity for its valorization into biochar and subsequently into activated carbon. So we have there are many attempts that produce or process this kind of biomass waste. Different processes exist to valorize biomass feedstock to produce economically and cost-effective value-added products such as syngas, liquid bio-oil, and solid biochar for society. And then for the third one, critical applications, most of the production of the AC has been used in filtration, energy storage systems, and various industrial processes. Most of them are focusing on the quality and the quantity that has been produced, and lack understanding in terms of the thermal decomposition kinetics to optimize production, how to improve the product quality, and also unlock the full industrial and environmental potential. So the objective for this project is to investigate the complementary relationship between thermal decomposition kinetics and the characteristic of coconut frond activated carbon using all those activating agents. I narrowed down the objective into we are focusing towards thermal reactivity and activation energy of carbon samples that we use two types of models to investigate and to reconfirm the reactivity in thermal, and also we study the study also examine how different activation agents and methods affect biomass composition, surface morphology, textural characteristics, and also thermal stability. And the last one, how activation process influence thermal behavior, pore structure, and surface functionality, aiding the design of biomass-derived carbon for environmental and energy-related applications. And this is the methodology to complete the objective. The first one is the sample collection and also preparation. Basically, for coconut fronds, we collected it from the local area and we chopped into size like 3 to 5 centimeter before we dry it in the oven for overnight at 105 degrees Celsius in order to remove the excess moisture content. Further, then we grind and receive it from the size that we cut it into the particle range like 200 to 800 micrometer before we put it in a pyrolysis system. In this study, we use slow pyrolysis and it is carried out at 500 degrees Celsius with 5 degrees Celsius per minute heating rate and a 2-hour holding time. So we produce like 1 gram for 200 gram feeder per batch. And from the products that we produce, the biochar, we determine the calorific value analysis HHV, and also we determine the cellulose and lignin contents via wet chemistry following standard methods such as ASTM 110360 and also ASTM 110696 respectively. Okay, the critical methods is once we produce the biochar, we then further do the activation process using the chemical activation method. So the activated carbons were produced by mixing the biochar that we produce for 6 hours with different activating agents, KOH, C4H5, malic acid, and also H3PO4. We impregnate it with the ratio 1:1, followed by the carbonization process at 800 degrees Celsius for 1 hour in a furnace. Okay, and then in this study, I will use ACQH, ACMA, and also ACPO1 as the name of the samples for the activation product. And those samples has been undergo the sample characterizations followed by thermal kinetics investigation. Okay, next, for the results and discussion, the preliminary analysis of the composition of the coconut frond biomass was determined using proximate lignocellulosic and higher heating value analysis. So the proximate analysis results including the percentage of volatile, moisture, ash, fixed carbon. And okay, we compare our work with the literature review to look into the potential and also to make a in situ comparison with the existing one. For this project, HHV represents the total amount of energy released when the biomass is completely combust. It tells us how much usable energy you can extract per unit mass. So from here we can see our work is 20 and the previous one is 19. So higher HHV is equivalent to more energy rich feedstock, which means that better for bioenergy applications. Next, we proceed with the SRD. This figure shows the SRD patterns of ACQOH1, ACMA1, and ACPO1. As you can see here, all of these samples shows a pattern or exhibit a broad peak at 002, 2 degree at 22.9 something, which is ascribed to characteristic of disordered carbon structures. And the superimpose of this amorphous background are several sharp peaks like 28, if we close up into 28, 40, 50, and also 58 until 74 here. It's confirmed the presence of mineral crystals within the samples. It's normal for the biomass sample. However, the ACMA, for the red color one, sample features a pronounced diffraction peak around low 2 theta, like 21.7, with no distinct crystalline peaks, indicating the predominance of an amorphous phase with a probable high microporosity. So meanwhile, for the ACPO1, the green line shows a broad peak with a small shifting at 27.2, which corresponds to the turbostatic carbon. So the broader peaks observed in ACM1 and ACPO1 indicate a more disordered and porous carbon structure, which is typically beneficial for absorption applications. So next, we have done the FTIR to confirm the chemical compositions. So basically, it reveals the broad band observed for those samples at 3,600 to 3,200, which attribute to the hydroxyl groups due to the presence of water, phenols, and also alcohols. This one is typically from the coconut materials itself, and the peak at 1,700 here correspond to the C double bond O in hemicellulose lignin and pectin. The presence of OH and carbonyl C double bond O and also OH suggests enhanced hydrophilicity and polar pollutants absorption. Meanwhile, the peak at 1,600 was assigned to C double bond C aromatic structures, which indicates partial derivatization, contributing to the material structural stability, which indicates during the high temperature applications. And all these bonds confirm successful chemical activation, which is known to promote mesoporosity and introduce phosphorus functionalities that can enhance heavy metal absorption. Now, moving forward to the next one, TGA, and also this one is the TGA for the samples, 3 stages of decomposition. So I have divided it into region 1, 2, and 3. Region 1 is less than 150 degrees Celsius. This one is about moisture loss. Initially, transition temperature due to the abbreviation of water. From here, ACPO1 shows highest moisture loss due to more hydrophilic groups. Okay. For the region 2, like in between 150 to 400 degrees Celsius, this one is volatile release and hemicellulose-cellulose breakdown region. There is a sharp weight loss due to volatile release, particularly in ACKOH, the blue line. The fast decomposition due to KOH catalytic effect leading to earlier breakdown. Meanwhile, the last region, we found that the major weight loss due to lignin degradation. Weight loss for the ACKOH is about 30.47%, is higher than those ACPO1 and also ACMA1. Next is DTG. So for the DTG, this one is still TGA. So here the reason why the ACQH having shows a more significant degradation because it decomposes faster due to the catalytic effect of KOH, and it shows a low thermal stability as compared to other samples. As compared to ACPO1, the stable phosphate complex make it more resistant to be degraded. And also for ACMA1, it indicates highest thermal stability because of fewer surface functional groups, as confirmed in FTIR1. For this one is the DTG. For the DTG itself, actually, I can summarize that it follows the trend from the that we shows in the TGA form. Alright, whereby the ACQOH is lowest than the other samples. Okay, moving towards to surface morphology. Figure 4 here presents.
Doctor, excuse me, doctor.
Yes.
Can we jump to the conclusion because we already dragged
okay.
our time?
Oh, all right. So basically, this ACKOH has shows a highly fragmented structure. In second figure, this one is bare. The rest is the ACMA1 and also ACPO1. Okay, you can see that the ACKOH effects is more significant as compared to other samples. All right, and then this is the EDX structures. So the composition of the carbon is highest, and also for this. Okay, maybe I can show like 1 or 2 minutes about the kinetic parameters here, about the CRM and also the MVRM that we use, the models that we use to validate our thermal decomposition reaction for the activate carbon that we produce. So basically here we can say that the activation energy for the ACQOH is highest after the raw biochar as compared to others. Okay, and this one also aligned with our MVRM model that we found that ACQOH is in the middles, is just like slightly above than the biochar itself. So when we did these two models, we found that the activated carbon, especially ACMA1 and ACPO1, show low value of activation energy and B, indicating enhanced reactivity due to the activation in this structure. So we did some market analysis from this overall presentation. I can say that this work has presented a low cost, like we calculated it for $0.2 just for coconut from biochar as compared to the commercial one, like they are selling as in between $2 to $5 per kilogram. As a finding, the activation improved thermal stability and reactivity. ACMA and ACP1 had the highest reactivity indices. This one is triggered by the energy activation and also the R squared just now. So last but not least, I want to acknowledge our fundamental research grant, FRGS, and also university grant from USM. So thank you for listening.
Okay, thank you, Dr. Norafiza. So any question from the audience? Any question? Maybe from judges? Doctor, I have one question from regarding your research. Okay. How do variation in slope, pyrolysis temperature, and residence time will affect the yield, surface area, and pore structure of the AC or activated carbon that come from the coconut fronds?
Oh, thank you for the question. What I understand is how does the temperature for pyrolysis affect the yield production, right? For the biochar.
Yes.
Basically, we classified the temperatures according to the type of the biomass itself. Is it under non-woody or woody? In my case, this one is under woody plants. So from our research, we found that the temperature used within 500 to 550 for woody plants or woody plantation waste is appropriate to get biochar like 60 to 70% of it, because the it is depending on the type of the biomass actually.
Okay, thank you, Doctor. Okay, next presentation from the Dr. Nafis. There's one question from the Dr. Lam. What are the real world applications of activated carbon derived from the coconut fronds, and how does it perform compared to activated carbon produced from other biomass sources? The real world applications of activated carbon.
Thank you, Doctor. Actually, what we have done is activated carbon that we produce has been implemented in the supercapacitor, energy storage, and also dye-sensitized solar cells as the electrodes materials. And the performance so far is comparable. It depends on the quality and types of the biomass that we use for coconut front. It shows comparable in terms of supercapacitor. I can say that we can get like 200 farad per gram for the specific capacitance that we obtain. And that one is the activated carbon that we use from the coconut front.
Okay, then how about the comparison with the others of the activated carbon from the others biomass sources? The performance of the activated carbon from the coconut fronds.
Okay, so to answer this, I'm looking into what we have done in our lab, especially we have done oil palm, from the coconut, from the bamboo, banana, and so on. And so far, the woody plants give the highest performance as compared to the non-woody. That can I say just now.
Okay, thank you, Doctor. Okay, thank you very much. Okay, so next we move to our next presenter, which is Dr. Lam, Wichen from the UMK. So Dr. Lam, you can present your project now.
All right, good afternoon, everyone. Testing. Can you hear me?
Yes, we can hear you.
All right. Oh, can you see my slide?
No.
No?
No. Blank.
Okay, just wait a minute. Okay, how about now?
Still nothing.
Okay. Can you see it?
Nothing. I'm still nothing.
Okay, sorry. Just wait a minute. Okay. So should be. All right, can you see it now?
No, don't have anything at the surface. Maybe from my side I
Okay.
cannot see, but others I don't not sure. Others also cannot see the slide.
Same. Cannot.
Still nothing, Dr. Lam. The screen is still blank.
Okay. Why not? Session. Room 2. Still no? Can you see my screen?
Cannot see, but Dr. Nofiza
can you
mentioned.
use the screen?
Yes.
Can you go to the next slide? Perhaps the first slide is blank.
Okay, okay. I will try.
No, we cannot see.
Still cannot see because maybe I'm not sure about the connection because the connection sometimes lost.
Okay. Still not see my slide? It's okay. I will try. Okay. Sorry for some technical issue. Can you see now? Or still not showing?
Still cannot see anything. Maybe we can try
with
to move to the
next
next
one.
presenter
Yeah,
first.
okay. Yeah, sure.
Maybe you can fix his first. Then we move back to your
Yes. Okay.
presentation, Dr. Lam.
All right.
Okay.
Thank you, Dr. Dayani. All right.
Okay. So we move to the one Suryani Fali Adiba, one Ibrahim. Dr. Fali.
Yes.
Okay, Dr. Fali. Start share your presentation now.
Okay, hold on. So can you see my screen?
Okay, clear.
Wait. Okay. Hello, Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, good evening, everyone. I'm Wansrani Falik Adibawan Ibrahim, and today I'm going to present to you a paper on activation of nitric cells cytotoxicity by methanolic leaf extract of Abrus precatorius in breast cancer cells. And this is a work done with this group of people from USM as well. How do I go to the next slide? It's not moving. Right, ladies and gentlemen, cancer, cancer are abnormal cells, right? So that grow out of control. So scientists has described this ability of the cancer cell to grow out of control as the hallmark of cancer. So there are signs of why the cancer cells emerge. And one of it, or a few of it, like growing without stop, and it avoid cell death, and also spread to other tissues. And the main important one I want to highlight here is on here. It's called as escaping the immune system. All right, so it avoid the immune system. So normally, how do I want to say this? Just imagine that your body, because our immune system can detect and destroy dangerous cells. So NK cells, as one of our immune system, they are like soldiers on patrol. Okay, so because the highlight for today in my presentation, I want to talk about nitric killer cells, part of the immune system that inside our body. So what is nitric killer cells, right? So basically, these cells, they are like soldiers on patrol. They will look for cells that are damaged or infected, and they are going to destroy them, right? But however, cancer cells can hide their signal, and they can release confusing chemical that allows them to avoid this soldier, this surveillance, and therefore our NK cells cannot detect them. And that's why the cancer cells keep on growing and spreading. So it's our aim to understand how can we boost these NK cells and to help their role to fight cancer better. So this is what I'm going to talk about today. It's called about nitric killer cells. Now, nitric killer cells, they are part of white blood cells as well. They will, as I mentioned, destroy and also infect and disease cells, such as cancer cells. It is a type of lymphocyte, like B cells, T cells, also cells that have been preventing virus and also cancer cells from spreading. Now, what is its role in cancer? It is the first line defense against tumor cells. How? They will downregulate the activating ligands, upregulate the immune system. It has a balance of signals from activating receptors such as NK, nitric killer cells, D2D, and also inhibitory receptors. So these need to be balanced. And also it will recognize the MHC1 recognition. So a healthy cell will express MHC1 that will inhibit the NK activity. And tumor cells with low MHC1 will trigger NK cell killing. So NK cells identify target cells like tumor or virus infected cells that has low or absent MHC expression, or express induced ligands. But the key advantage of why NK cells is important because it is rapid response. It acts without prior sensitization, and it's not specific to antigens such as T cells. So they don't need any antigen to present, and it is a control killing, apoptosis, which will limit tissue damage. So in this case, we want to look at these two things, perforin pathway and also granzyme pathway. In a simplified version, I would say that perforin is a pore-forming protein that stores the NK cell cytotoxic granules. So when perforin is released into the target cells, it will open the pore and then will create a pore, and then the granule enters and kill the cancer cells from within. So this is how NK cells work. Now, but how do I say this? That our immune system sometimes it needs something to boost, right? To boost our immune system, the natural system. Sometimes it needs something to work better. We need something to push. So contains lots of phytobioactive compounds that are known to enhance immune cell activity, and some can help to activate NK cells. And in our group, we study average. There's two types. One is the red seed, but this one, it is a we have identified, we did active chocolate extraction. We found out that they have strong this compound for vinylphenol and also neophytidine. And we found that the methanolic extract from this extract induced apoptosis in MDA. And we are going to take this point onward for to see whether or not APME, average respiratory methanol extract, can enhance natural killer cells. So the objective of the study, as I mentioned earlier, is to observe the ability of that APME, average respiratory methanolic extract, to induce the natural killer cells activation in co-culture experiments. So this is something that we did in this study. We did a co-culture experiment with breast cancer cell MDA MB231. Using NK cells isolated from two individuals, donors. They are healthy, and also breast cancer patient donors. So, as I mentioned earlier, we did a successive chocolate extraction over here, and we found that the methanol extract works better works the best on these MDA MB231 cells, where we did further analysis to go and look. We did further analysis for the NK cell study, where we collected NK cells from healthy donor and also breast cancer patient donor. We isolate them, we co-culture them, meaning first the collected NK cells, we extract, which is the APME extract. After the activation, 24 hours. The next day, we spin it out and then we put them together, co-culture it with the breast cancer cells. Together also with breast cancer cell and also with the extract. The second group is NK cells alone with only the breast cancer cell, MDA MB231. The third group is the NK cells with the MDA MB231 and DMSO as the control. The fourth one is the NK cells only, and the fifth one without the NK cells, just the original study where we took the extract with the breast cancer cell only. So we co-culture them, and then we analyze the result. We look for cell death and some signals to see their response. Okay, so what did we get? Okay, so these are the NK purification on how we get that. We didn't get 100% purified, so it has some cells that comes together as well. However, we found out that higher NK cells are significantly higher in healthy donor as compared to the breast cancer patient donor. So it's about 7.72 times 10 5-fold cells per mil versus cancer patients. This is because breast cancer patients often have fewer and also weaker cells, as mentioned by these papers. Why? Because the low activating receptors of the NKG, 2D, and also NCR, and also higher inhibitory markers that makes that hinders the NK cells mechanism. So the impact is that it will reduce the NK cells killing ability, and also to reduce the therapeutic potential. So I'll show you more. Okay, so this is the NK cells count. Okay, this is in the healthy donor. So this is the first group over here, which is the NK cells with the breast cancer cells and also the extract. And these are the controls. And we can see that in healthy donor, the significant difference we can see in within the first group, the test group, with the control group. However, in a cancer donor, we can't see much changed. Okay, so here, this one is the NK cells count, but here is the apoptosis, the program, the cell death. We want to see whether the percentage of the MDAMB 231 cell death between the groups in the healthy donor and so the cancer donor. So we can see that higher cell death versus untreated or DMSO control in our healthy donor, but failed to induce any significant cell death, all right, regardless of the treatment, regardless in all group, there's no change. So it just shows here that our extract, the extract can boost the NK cytotoxicity only in the healthy donor of the NK cells. So this is when we put it in this way, the NK cell cytotoxicity, you can see obvious significant result of how the NK cells able to kill the cells in the presence of the what do you call it, the extract. Okay. Now, it just shows that the NK cells are not functioning well in cancer patient. This is what we call as the impaired cytotoxicity, which reduce tumor cell killing. It will decrease the cytokine secretions like interferon gamma, perforin granzyme B, loss of activating receptors, or it upregulate the inhibitory receptors that inhibit the actions of the NK cells. And this is what we call as the NK cell exhaustions or poor activation response, which lower the therapeutic potential. These are the cytotoxicity that we measured, the interleukin-2, interferon gamma, perforin, and also granzyme B. As I mentioned earlier, if we want to understand what's the function of interleukin-2, I would say that it is like a fuel. Interleukin-2 is to activate or to proliferate NK cells. So this is what we have measured. Interferon gamma is an alarm signals produced by the NK cells to alert and activate other immune cells to slow the tumor growth. So we can see that the extract can boost the interferon gamma production, proving that it can trigger NK cells to fight cancer cells effectively. But look at this graph. You can see that in cancer patient, it has higher interferon gamma production. However, if we go back to this, we can see it doesn't show any significant cytotoxicity. And that is a big question. Why? Now, perforin, as I mentioned earlier, it is a protein that opens the pore of the cancer cells in order for the granzyme to enter and kill the cell from inside. And we can see here that, again, in cancer patient, it is significantly higher as compared to the healthy donor. However, it is impaired. See, it is because of the residual dendritic cell or T cells. Significantly increase in the APME treated NK cells in healthy and cancer donor. But see, as I mentioned earlier, weak killing, it shows less cytotoxicity. Perforin 1 elevated in healthy cancer matches strong cytotoxicity. Cancer donor increased but not significant. Granzyme B low in all groups suggests that perhaps there's another pathway that shows the killing ability. We can say that the APME activates the NK cells strongly in healthy donor, enhancing the interferon gamma and also perforin 1. However, the cancer NK cells remain less responsive. Now, ladies and gentlemen, this shows that APME stimulates the NK cells growth and killing ability, the cytotoxicity. The enhanced interferon gamma and perforin 1 confirm the NK cells activation, also anti-tumor response. Why cancer donor show limited responsive? Perhaps it happens because of the low activation of the receptors or increase in inhibitory checkpoints. This is what I call as immunosuppressive tumor microenvironment. So the outcome, we can say that APME benefits NK cell-based immunity in healthy individual, while cancer patients, NK cells may require immune reactivation strategies. Ladies and gentlemen, that is why I like to explain this to people, that we have to take care of ourselves while we are still healthy, to ensure that our immune systems are ready to do the surveillance. While they're doing the patrolling surveillance, they want to kill the cancer cells. So we can say that in conclusion, we found that the APME can increase the NK cells proliferation, enhance the cytotoxicity, leading to the apoptosis of the target cells, increase the expression of the cytokine and also the perforin-1 proteins. However, in NK cells, the cytotoxicity was impaired and showing no significant improvement. So, ladies and gentlemen, please take care of yourself. We suggest that potential of using this Erbis picatorius as a dietary herb in healthy individuals, possible role as a cancer prevention rather than a, how to call it, like a treatment. Prevention is better. So to support the NK cell activity. However, of course, a further study is needed in order to confirm all these theories. All right, so we'd like to acknowledge this for the Malaysia USM short-term grant. And these are the references, and thank you.
Okay, thank you, Dr. Fali. Nice presentation. But I have one question based from your research. There's a set, Dr. Siti Fatimah. Okay, what are the active compound present? Same question like what I mentioned. What I want to ask the question for you. What are the active compound present in the methanolic leaf extract of Erbis that may contribute to the NK cell activation?
These are the two extracts that we found that these are the 4-vinylphenol and also neophytidine. It belongs to the flavonoids group. The one that we feel perhaps responsible to these cytotoxicity function.
How?
Because
actually,
this was done in the previous study, which I didn't explain more in this one.
Oh, okay. Yeah. So actually, what is the difference? Like if the healthy person take these herbs, okay, compare with the person that already have breast cancer. Okay, you mentioned that there's a comparison, like okay. So what is the mechanism actually that makes if the consumed by the healthy person, okay, the mechanism can change their healthy lifestyle and so on if we consume this herb?
Not only these herbs, like most greens, okay, I would say most greens. This is what we found. Okay, it's a true story. Our donor, the two donors, they are very weak. Their NK cells very low. But one of the donor, we found that it's nice. It's better than the other two. 3 of them, they're all sick. They all have cancer. They are all breast cancer patients. However, the healthier patient, the way that she maintained her lifestyle is that she always consumed all these greens. We believe that by consuming greens, because of the antioxidant function ability in all these greens, it helps to boost the immune system, in particular natural killer cells, to make it healthier. The impaired NK cells, you see the number here. I'll show you again once again here, over here. You see the impaired here, the cancer, the significant, they are very different between the healthy and also the cancer donor. It means that when you are already sick, your body cannot produce or cannot make the NK cells better. I mean, like produce more NK cells. I would say that. Specifically how, the mechanism, we are not sure. But theoretically, there's a lot of studies also found the same thing. The NK cells is higher in healthy individuals rather than the cancer patients individuals. Mainly because when you're sick, your immune system is down as well. And remember, when I show you this one here, one of the reason why the cancer emerge is because of the ability of the cancer to avoid the surveillance. It means that the immune system is already weakened, then the cancer can emerge. If your immune system is stronger, then they can kill the cell on target. Mm.
Okay, thank
So
you.
consume more greens.
Okay, thank you, Dr. Fali. Okay.
All right.
Okay. Then we move back to the Dr. Lam. Dr. Lam?
Yes,
You hear
I'm
Dr.
here.
Lam?
So,
Okay.
hi, good afternoon, ladies
Uh,
and gentlemen. I'm back. So let's hope it works this time. All right. So now, can you see my slide?
yes. Okay.
All right.
Okay.
All right. So without further ado, I think I will start my presentations. All right. Okay. All right, so please bear with me. All right, so good afternoon, everyone. So I'm Lam from the Faculty of Bioengineering and Technology, Universiti Malaysia, Kelantan. So today I'll be presenting the development of eco-friendly bamboo particle board fabricated using citric acid and tapioca starch adhesive system, with the focus on the influence of pressing temperature and time. All right. So just to give you a little bit of background about this research. So recently, there's a growing regulatory and consumer-driven push to eliminate the formaldehyde-based adhesive in our country. For example, the Malaysian Timber Industry Board, MTIB, actually they push for a low formaldehyde wood-based panel. And in order to achieve that, so we can substitute the petroleum-based adhesive with citric acid as the binder. And citric acid is considered a promising binder because of its trifunctional carboxyl functioning group, which can esterify to form an ester bond with lignocellulosic substrates in order to yield a very low formaldehyde emissions, but also with improved dimensional stability. So here I might want to explain why we want to, why don't we produce a zero formaldehyde or VOC emission particle board? Because the wood itself, actually, they have a free formaldehyde emissions, the same as our body. So that's the reason we can only substitute the adhesive, the petroleum-based urea formaldehyde adhesive, with other green adhesive, but the wood itself, actually, it will also contain and emit formaldehyde. All right. And why do you want to substitute formaldehyde? Because formaldehyde is considered as a carcinogen, which can cause cancer. All right. So if we substitute citric acid with the urea formaldehyde emissions, and the board we produce will give very strong, very good dimensional stability, but normally with a lower mechanical strength, structural strength, and stiffness. So therefore, in this research, we try to incorporate tapioca starch, which is a renewable polysaccharide, into our formulations, into the citric acid formulations. And early studies on the agricultural residue board shows that the starch additions into the citric acid can reinforce the acid-mediated cross-link and enhance the mechanical durability. But the synergy between the pressing parameters, the pressing time and temperature, on the physical and mechanical properties of the citric acid and starch bonded particle board remain poorly understood, especially for bamboo particle board. So in this study, we used two new raw materials for the production of conventional particle board. So one, the raw material, we substitute the tropical mixed hardwood with bamboo. And the next material, which is the adhesive, so we substitute the petroleum-based urea formaldehyde with citric acid and gelatinized tapioca starch. All right. So this is the the chemical structure of the citric acid. So as you can see here, the citric acid, we have 3 functional groups, which can bond with the lignulosic substrate. And why do we want to add gelatinized starch, not just using the citric acid itself? Because as you see here, the self-condensation of citric acid will create a very low polymerization degree of the polymer chain. So if we add in gelatinized starch, which will free up a lot of the hydroxyl group, which can bind with the functional group of the carboxyl group of the citric acid, and one chain of the gelatinized starch will contain hundreds of active sites of the OH active sites, which can then be bonded with the substrate of the wood. So that's the reason we want to add in a gelatinized starch in our study. All right, so the main objective is to determine the optimum pressing temperature and time for particle board bonded with citric acid and gelatinized tapioca starch. And the specific objective are to evaluate the effect of different pressing temperature. In this study, we use 170, 180, and 100. There's some typo here, and 190 degrees Celsius. So we want to study the different temperature on the mechanical and physical properties of particle board. So next, we use different pressing time, which is 4 minutes, 8 minutes, and 12 minutes. So this is the parameter that is being used in this study. So the gel, as I mentioned, we use gelatinized starch, and in order for us to produce the gelatinized starch, we add in 4% NaOH, sodium hydroxide, into the gelatinized starch in order to help it to form a gelatinization. All right, so this is the methods. How are we going to prepare the particle board? So first, we collect the bamboo particles, and then we make it into a bamboo chips with a match size of about 40 to 60. And after that, we produce a gelatinized starch mixture. So after the gelatinized starch is produced, we mix it with the citric acid. And after that, we blend it as usual, as the conventional method, with the bamboo particles. And then we do a matte forming and pre-pressing. After that, we press it using our studied parameter with different temperature and time. So after we produce the board, so we determine the mechanical and physical properties of the board. All right, so this is the summary of the results of the mechanical properties of the particle boards, of the particle panel produced from the buloh madu in this study, which in the scientific name, Gigantochloa arbociliata, under different pressing temperature and time. So as you can see here, for the particle board, press under 180 degrees Celsius for 12 minutes will give us the highest strength, highest modulus of rupture, correspond with the highest modulus of elasticity. So with 180 degrees Celsius and 12 minutes, we will get the MOR value of 13.7 and the MOE value of which is about 3100. All right, so this is just to show you the graph. So this is the effect of pressing temperature on time on the mean modulus of rupture of particle board. So if you see here, so the green line, green dotted line here, actually, that is the requirement stated in the standard. So in our research, we are referring to the JIS standards. All right, so the standard we use is JIS A 5908. So according to the standards for type 13 particle boards, so of course the MOR of the board need to be 13 and above. So as you can see here, our particle board produced with pure citric acid, with gelatinized starch, we can achieve the requirements stated in the standards. And with a very high MOE. So that the MOE stated in the standards for type 13 particle board is 2,500. And the samples we get is well above the required standards. So now let's look at the physical properties, which is the thickness swelling and water absorption of the board produced. So as you can see here, for the same processing parameter, 180 and 12 minutes. So we get the thickness swelling, which is 8%, and the water absorption is 72%. So if you see here, even though this is not the lowest, but the lowest thickness swelling and water absorption is produced by the 180 degrees Celsius and 12 minutes. But if you see the corresponding physical properties, which is very low. So the mechanical properties, the MOR, for the lowest thickness swelling, which is just 5. And that doesn't meet the standards. All right. So that's the reason we choose 180 degrees Celsius and 12 minutes for the optimum as the optimal pressing parameter. Okay, so you have to remember in this case, there's two properties we need to achieve. We need to produce a board which is dimensional stable, meaning the thickness swelling of the board must be below 12%, and the mechanical properties of the board, the MOR, need to be 13 and above. So that's the reason in our case, 180 degrees Celsius for 12 minutes is the optimum temperature. All right. So as you can see in this graph, again, the green dotted line here is the 12% of the thickness swelling, which is the minimum requirements required by the standards. So for thickness swelling, the lowest, the better. And for the mechanical properties, MOR, MOE, the highest, the better. All right. All right, so now I will go to the conclusion of the study. So this study demonstrated that both the pressing temperature and pressing time significantly affect the physical mechanical performance of bulung madu particle board bonded with citric acid and gelatinized tapioca starch adhesive system. And the lower the temperature or shorter pressing time yielded undercured and delaminated panels, while excessively high temperature will risk thermal degradations. And the board pressed at 180 degrees Celsius for 12 minutes achieve the optimal properties of MOR, MOE, thickness swelling, and also water absorption, which all the properties mentioned here exceed the GIS standards for type 13 particle boards. All right, so next, this is future research directions for this study. So next, for future research, we can explore the effect of bamboo particle size and the geometry distributions and the board density on the mechanical properties and dimensional stability of the particle boards. According to the standards above type 13, we have type 18, type 23. So in order for us to produce a higher grade of the particle board, so we need to explore other aspects such as the bamboo size particles, the geometry distributions. All right, and the next one, we can also assess the long-term dimensional stability and durability under cyclic humidity and temperature conditions. We can do accelerated testing, UV testing, in order to test how does our board, particle board, produce with this green adhesive compared to the conventional for urea formaldehyde particle board. And the next one, because in this study, this is just a very preliminary and fundamental study. So we only test for the mechanical properties and dimensional stability. So in future research, so we might want to test, carry out more testing to study the underlying mechanism. How does this carboxyl group from the citric acid bond with the OH group of the starch and also the OH group of the lignocellulosic substrate? How does it bond to the cellulose surface or to the hemicellulose and lignin surface of the wood? So we can incorporate other methods in order to determine the the underlying mechanism. All right. So actually, this work is supported by UMK Fund, and this is my reference. So thank you for listening. So that's all from me. So if you have any question, feel free to ask.
Okay, thank you, Dr. Lam. So, any question from the audience?
Okay, Dr. Lam, I'm Boon. I have two questions actually. Okay, the first
Yes.
question is, what is the moisture content of your bamboo chips before the mat forming? Okay, that's my first question. And my second big question, based on your opinion, what is the possible reason that caused the decrement in the mechanical strength after the 180, which means when you reach the 190, there's a decreasement, right? So what might be the reason for it? Okay, thank you.
All right. Thank you, Dr. Boon, for your questions. So in order to answer your first questions, so the moisture content, so that is a very important parameters when we produce our particle board. So for citric acid particle board, so the particle moisture contents is dry to 3% and below. So the maximum is 5%. So for urea formaldehyde particle board, the moisture content for the particle, the allowance is higher because the solid contents for urea formaldehyde normally is higher. So in our case, actually, we have a lot more water in our citric acid adhesive. The viscosity is also lower compared to the urea formaldehyde adhesive. So that's the reason, in order for us to avoid delaminations, we need to dry our particle board to 3%. So the maximum is 5%. So this is to answer your first questions. And the second question as to why the mechanical properties drop after 180. So this might be, we don't do a testing, but they should study the underlying mechanism. But I presume that's based on the literature, because once the temperature reach 190, so some of the components of the wood will degrade. So the degradations temperature for lignins is a very wide range. So starting from 150 to 100 to 900. So some lignins, and especially for our bamboo particles, so the lignin content is much higher compared to the other wood materials. So maybe that's the reason that when we increase the temperature, so the degradations to the chemical constituents of the wood happens, and that's actually will degrade the OH group, which is the active bonding sites. So that's the reason the mechanical properties will also decrease. So I hope that answers your question.
Okay, thanks for your sharing.
I got one question.
Okay. One question, okay, from Dr. Wan.
Dr. Lam, I
Yes.
have one question.
Yeah.
Okay,
So what
how about the
question for-
production cost to produce that
Dr.
particle board?
Sakina. Dr. Sakina.
Yeah.
Dr. Wan Mom, sorry. Dr. Wan Faizal want to ask first.
Okay, all right.
Okay.
Tunggu, wait first.
the bamboo
Right,
species
please,
that you
Dr.
choose?
Wan.
Any investigation? Can you hear me?
Yes, but there's an echo.
Oh, I see. Wait lah. The bamboo species that you choose. Any
Yes.
justification?
Yes, for one is availability, of course, and the second reason compared to because before that there are two species that I choose. One is bulu minyak and bulu madu. So when comparing the two, so actually bulu madu give a better properties, and also because of the wall thickness of the bulu madu, the diameter is smaller for bulu madu, but the wall thickness is higher compared to other bamboo. So that's the reason we choose bulu madu in our case. So if we choose other bamboo, which is a very large diameter, but very with a smaller wall thickness, meaning there's a very hollow section of the bamboo. So when we considering, so maybe that will answer some of the question of Dr. Sakina. So when we want to transport the timber, so that will add cost actually to the transportation of the bamboo for future productions. So I hope that answer your question.
Okay, thank you.
And
Okay,
Dr.
Dr. Sakina?
Sakina?
Okay. Okay, I have one question about
Yes.
the production cost to produce that EcoBot. So how about the production cost to produce? Because that board we know that that board use citric acid. So the cost of citric acid is lower or
Yes,
higher than
for our
synthetic resin?
preliminary study. So actually, the cost of the raw material, the bamboo itself, actually is lower because of its high abundance compared to tropical hardwood. So the cost of the raw material is lower, of course, and then the cost of the citric acid actually for the mass production is also quite easy. So the cost is also lower compared to the urea formaldehyde additive. So we don't have an exact value, but based on the basic productions of these two materials, so we presume that the overall cost will be lower.
Okay. Thank you, Dr. Lam.
Thank you, Dr. Sakina.
Okay, thank you. Okay, to all of you. Okay, now we move to the, thank you, Dr.
Alright.
Lam.
All right, thank you.
Okay, now we move to our last presenter, Associate Prof. Dr. Wan Muhammad Faizal Wanisa from the UMK. Okay, Prof. Wan, this floor is yours. Okay.
Okay. Dengar suara saya? Dengar,
Clear?
Dah sebab komputer saya ni tak function suara. Tahu saya guna handphone. Sekejap saya share slideshow. Share. Okay. Okey. Boleh nampak
Tak nampak apa pun.
Ya.
Okay, clear? Okay, Prof. Wan, boleh present?
Okey. Boleh dengar Sorry. Termute tadi.
Patutlah. Okay.
Kejap saya pun tak buka ni lagi. Tak buka apa? Kejap Aduh. Kejap. Buka video. Okay. Today I want to share with you my project. I think this is
Tak dengar lah.
dengar tak?
Dengar.
Sorry. Today I want to share with you the sustainable ceramic water filters from rice husk waste. This project we did with one of industry in Kelantan, Machang, for transforming agricultural waste into effective water purification technology for developing communities. So agricultural waste crisis, we always have a problem with the waste, which is significant agricultural byproduct with global production exceeding 150 million tons annually. And traditional disposal methods include open burning, and then it causes air pollution, or landfill disposal, which wasted resources. So we have water quality crisis as well. We have 2 billion people lack access to safely managed drinking water at home. Diarrhea disease claimed approximately 1.6 million lives in 2019, with children under 5 most affected. And 40% of Malaysia river basin shows declining water quality trends. So from these challenges, we come up with the idea how to overcome this problem of agriculture waste, and also at the same time to increase the water quality for our benefit of our people. So this research addresses both challenges by developing ceramic filter from rice husk derived silica for point of use water treatment. So rice husk, as we know, is a valuable resources which the contains cellulose, hemicellulose, lignin, silica, extractive, and ash. So this is the proportionate of percentage of every component composition of the rice husk with their own function. For example, the cellulose for structure support, hemicellulose cell wall matrix, and so on. So our process, we start with cleaning and pre-treatment using the to wash the impurities at the labs. We do with the distilled water. We do a drying 80 degrees for 24 hours, acid leaching with SCS solution, and final washing and drying. All this we do with all the equipment at the industrial lab, at Machang. And then after that, we place in the ceramic crucible, heating at 60 degrees Celsius for 5 minutes, and holding for 8 hours to cooling down, and natural cooling in ambient air. And then we do some characterization using the SRF, FTIR, SEM, and BET for surface area measurement. This optimized process yielded a high quality amorphous silica, 84.5% purity, with favorable surface properties, 115.74 meters square per gram surface area. And then we test our ceramic filter using five different combination of material. We name it S1 up to S5 with the clear percentage, RHA silica percentage, and sawdust percentage at different percentage each. And then the process, including the dry mixing clay, adding water to form plastic for synthesis, mechanical mixings and aging, shaping using plaster molds, air drying, then oven drying, and sinterizing at centering at 900 degree. So we got a result of physical properties of our ceramic filters with a porosity, percentage, and compressive strength, MPa. So we have different result for S1, S2, S3, S4, and S5. So from this, we do the test for removal of turbidity, ion removal, and turbidity and ion removal. For the result we can see there is the best one for turbidity is S3, 98.7%. Ion removal S1 85.3. So all the functional filter composition demonstrate excellent turbidity removal exceeding WHO standards. And for the ions, we have S1 and S2 improved ion removal through increased cation exchange capacity and the surface area of clay minerals. And S3 show the lowest removal, 57.3. Despite the lower ion removal efficiency, S3 still reduce ion content below WHO guidelines, i.e. 0.3 milligram per liter from the initial, because we use a very low concentration. So we still get a result beyond the standards. The superior turbidity removal performance for S3 significantly exceeds typical requirement for treated water, and no statistically significant difference were observed between functional composition for turbidity removal. So this mechanism for removal, as we have three types. We have physical straining, particle larger than 4 openings, typically more than 1 micrometer, are mechanically retained. This mechanism primarily governs turbidity removal, explaining the consistent high performance across all composition of our sample. Absorption, dissolved contaminants interact with surface functional groups on clay minerals and silica. Ion removal occurs through electrostatic attraction to negatively charged clay surface complexation, and silanol groups, and precipitate as iron hydroxide. For the depth filtration, smaller particles are captured within the porous matrix through interception, impaction, and diffusion mechanism. The hierarchical porous structure of rice husk derived silica enhance this process. So this is 3 different mechanisms that works with our silica filters. So performance optimization, the multi-criteria performance evaluation for the S3 composition achieved the highest composite score, 0.89 out of 1, representing the best balance between flow rates and contaminants removal. Our composite score calculation is flow rates 30%, turbidity removal 35%, and ion removal 35%. So overall, the S3 is the best, the optimum condition for our filter. While S1 demonstrates superior ion removal, it significantly lower flow rate, reduced practical applicability for household water treatment. So we study some economic and environmental benefit from for our study. In terms of cost advantage, 2.5 per liter USD, 3.2 times 10 power of 10, lower than commercial alternative. Raw material, 34% of overall cost. Processing energy, 60% of cost, and labor, 30% of cost. Second one, environmental impact, diverts 1.2 kilo of rice husk waste per filter, 40 to 50% lower processing temperature, 35% reduction in energy consumption, 60% lower CO2 emission with imported filter. So all this we do the comparison with our product and the market in the market. In terms of market potential, we do the study in the market potential. We have 50,000 household units could benefit in Kelantan only. USD 1 to 5,000 annual market value for local producer and create value added opportunities for rural communities. So the market is big enough for commercialization. And if I'm not mistaken, the company that we worked together last time, they already produce based on our collaboration, this collaboration, they already market the product in the with their brand. Limitation and future research, we have current limitation, we use only low flow rates. Maybe we can use industrial scale for next research. Comprehensive microbiological testing, need to validate pathogen removal efficiency. We didn't do any microbiological tests. Extended performance study required to establish realistic filter lifespan. So this also we not did. A future research direction, process optimization through response surface methodology, surface modification with silver nanoparticle and iron oxide, pilot scale production trials to validate commercial feasibility, and field testing for real world performance evaluation. So this is our next direction in this research. Finally, we have a few takeaways. Our waste utilization successfully transformed agriculture waste into valuable water treatment technology. Optimized performance, S3 composition, 55% clay, 20% silica, and 50% sawdust. Achieve excellent contaminants removal with practical flow rates. Cost effectiveness, production cost $2.5 per liter are 3.2 times the power of 1, lower than commercial alternative. Environmental benefit, reduce energy consumption by 30% with 60% lower carbon footprint. A global impact provides affordable water treatment solution for communities with limited access to safe drinking water. So this is answer our first problem statement in the first slide. So with that, I thank you.
Okay, thank you, Prof. Wan. So, Prof. Wan, there has one question from Dr. Rosmawani. Okay, Assalamualaikum, PM Dr. Wan. In your opinion, does rice derived silica have strong potential for commercialization in the water purification industry? Tak dengar. Prof. Wan tak dengar.
Okay, sorry. Okay, thank you, Dr. Rose, for the question. Actually, we did this study with industry last 2-3 years, I think during COVID in our country. So, and at the moment, they already commercialize this product with their own brand. Yeah, so the future is there. The future is there.
Okay. So, any more question before we end of our session today?
No more.
No more. Okay. So that's all for our session. So before we end, before we end our session, okay, please turn on your camera. Ambil gambar semua.
Turn on.
Turn on. Okay. Okay. Okey, yang lain. Okey, 1, 2, 3. Okey. Alamak. Kejap, dia hang pula dah. Kejap dia hang. Okey, 1, 2, 3. Okey. Kejap, nak kena paste dulu. Okey, lagi satu freestyle. 1, 2, 3. Okey, done. Okey, makasih semua. Makasih semua. So hopefully we meet again for next conference lah. Okey, makasih. Assalamualaikum. Bye-bye.